All right, guys, welcome back to Science with Miss Stevenson. We are talking about sound energy this week. Remember yesterday we talked about how sound is vibrations through the air. Those vibrations can move through solids, liquids, and gases, but not through empty space. In order to hear sound, we have to be able to have those vibrations bounce off of something, so empty space will not allow us to hear sounds, because we have to have those vibrations so that the vibrations can travel into our ears, to our eardrums, and let our eardrums vibrate so that we can hear whatever is making that sound. So today we are going to talk about some properties of sound. We've got frequency and wavelength. Waves can travel in different ways. They can carry different types and different amounts of energy, but all wavelengths have certain properties. Frequency and wavelength are two of those. The frequency of a wave is the number of waves that pass a point in a certain amount of time. Frequency is often described as the number of complete cycles a wave makes in 1 second. A cycle is usually one vibration. Wavelength is the distance between a point on one wave and a similar point on the next wave. And that word length in wavelength kind of helps us remember that. It talks about the distance because we're looking at the length. Studying sound. One way that scientists study sound is by using oscilloscopes. Say that word for me. Oscilloscope. Good. An oscilloscope is a device that takes sound waves and displays the shape of the waves on a screen. If you look at the oscilloscope screen below, the signals are displayed on screen in the form of a wave. The compressions in a sound wave show up on the screen as crests, right here, or the high points on the wave, and the spaces between the compressions show up as troughs. So we've got the wavelength here between, and our troughs are down here, the low points of the wave. Notice how the pattern resembles ripples in water. Waves like this one can be made in water by tapping the surface of the water. The ripples are the crests and the troughs are the waves. All right, so crests are our high point, troughs are our low point, and that wavelength is the distance in between them. And the frequency is how many of these we see in 1 second. Pretty cool, right? All righty. And then here you can see the compression, again, shown as this crest. Compression here, shown as that crest. Remember, compressions are where those particles are really close together. Okay, next page. All righty. We're also going to be talking about pitch of sound. The pitch. People experience the frequency of sound as its pitch. So how many are in a cycle comes off as pitch. And pitch is how high or low a sound is. The pitch depends on the frequency of the sound wave. So objects that vibrate more quickly have higher frequencies. These objects have a higher pitch. So like a really high pitch sound like that is going to have a higher frequency. And those objects that vibrate more slowly have a lower pitch because they have a lower frequency. So the material of the object making the sound and its size and shape affect the pitch that you hear. A tuba, for example, which is a musical instrument made of many feet of brass tubing, they make low pitched sounds, like they're really woo. Some sounds are way too low pitched or high pitched for humans to hear. So that's why like dog whistles, if you've ever heard or if you've ever seen someone blow a dog whistle, you know, dogs go crazy, but we can't hear it because the pitch is way too high. All right, volume. When you describe a sound, probably one of the first things that we think about is the loudness or the volume of something. And you know that some sounds are louder than others. A jet engine, for example, makes much more noise than a car does. But what exactly is volume? Well, it's the measure of how strong a sound seems to us. The more energy there is in the sound wave, the louder the sound is and the higher the volume. The volume of a sound is related to its amplitude. Amplitude is the height of a wave measured from its midline. The higher the amplitude of a wave, the more energy it has and the louder it sounds. So you turn down the volume on the TV, as soft as it will go, and you can barely hear it. And then you turn it up as high as it'll go, and now you have to hold your ears so that they don't hurt. You have not changed the pitch, you have just changed the amplitude and its volume.